Hello and welcome to lesson 4 of week 6. In this lesson, we are going to look at iterators and generators in Python. My name is Mildred. We looked at functions in previous lessons, and when we look at functions, we see that we can put many logic in functions, and it helps us to be able to maintain and debug our code. So if we have a system, maybe a login register system, we might want to have a function that when we pass inputs through the function or arguments through that function, then it validates and holds all the logic to log in the user. We can have another function for sign up. And so when we want to change the logic of this, we just change the function definition. And so everywhere the function is used, it updates. And when we do all of this in functions, we call this functional programming. So in functional programming, input flows through a set of instructions. Each function operates on a set of inputs, and then it produces the output. So one advantage that we have when we do this most of the time is that it helps us to modularize system, helps us to test, because now we'll be testing each of the function and the return of the function. Now, when we look at an iterator, is the whole foundation of writing functional program. We have a list here, and when we want to loop through the list, we use like the for loop, right? The for loop expects an iterable object, which is this list, and we want to get an iterator that will iterate through this iterable. So anything that you can traverse through is an iterable. A list, a set, a tuple, a dictionary, a string. This is an iterable, and we can have an iterator that will go through that iterable. So we can write it for I in my list, right? And when we do this, we want to do something with that. So I is now the pointer or the iterator that when it comes to the first position, it assumes the value of Jane, second John, third Mary David. Now this whole process has some inbuilt things going on underneath the hood. There is an inbuilt iter function, written iter like this, and this function takes an arbitrary object and tries to return an iterator that would return the object's content or the elements. So if, for instance, the object that we're using now is not a list, let's say a number type, if it doesn't support iteration, it raises a type error. So anytime we want to say what is an iterable object, is any object that you can get an iterator out of. And so we've seen that with all those sequence data types. So let's experiment with the iteration interface so that you can get a deep understanding of what happens, because two methods are called when you try to iterate, and we have iter and the next. So let's say we want to create an iterator object is equal to, now we use the iter function, we write past the name of the variable my list. So iterator is equal to iter my list. If we want to go to the next item, we use the next, right? So let's say, for instance, A is equal to, we use next iterator. When we print A, it only gives us the next one, right? So it just goes forward and gives us the next value. So when we print A now, we see we have Jane, because now it's going next. When I now put B is equal to next, when you print B, it now goes to the next and prints out John. Can you see that? So if we do up to 1, 2, 3, 4, so if we do up to D, now we'll keep going next. Let's do up to D to C. By the time we want to print E, now it will raise an exception, stop iteration exception, because we've reached the end at this point. So let's print C and print D, and then now let's print E. So the last one should raise a stop iteration exception, because when you do A, B, C, D, there is nothing else. When it reaches the end, it has to stop. So let's clear here and run. So you see we have Jane, John, Mary, David, and now we have the next iterator, stop iteration, is now raised here because we reached the end of the sequence. So we can see how the iter and the next are implemented in an iterator. So you don't need to actually do this. We are just trying to show what happens behind the hood for an iterator for us to properly understand what a generator is and why generators are the way to go when you can use a generator in place of a function. Now a generator is a function that returns an iterator. So you see this next that we do, it only gives us the next item when we call it, and waits for us to call another next before it goes to the next. It doesn't just loop through and gives us everything at once. Like when we're doing a function, it evaluates everything and gives you a return statement. When you need to use it again, you need to call the function again as much times as you need to use it. But that's not the case with the generator. The iterator returns a stream of values, right? And when we call a function, we have local variables that we define within the function. And so once that function hits a return statement, these variables are destroyed. So every time you want to get a value using that function, you have to call the function again. So generators can resume a function where it left off. So instead of destroying, it continues from where it left off, like we saw using the next here like this. So we can just call generators resumable functions. Why are they better than functions? They're easier to implement, they're memory efficient, and we can use them to implement like an infinite stream of data, since they can continue from when they stop without storing this thing in memory. Okay, so every time we use a generator, it produces one iterator at a time. So instead of using a return, the generator uses the yield like this. So the yield sends back a single value at a time, but uses this to produce a series of results over time. When you want to do something like data that you want to be executed in batches, you can change several generators together to process data in stages. Let's, for instance, do an example of a generator function. Let's say we want to get a sequence of numbers from maybe from 1 to 50 or from 0 to 50, right? So let's call this generator function so it doesn't take any argument. We want to say for I in range, so we said 50, right? For I in range 50, we want to do something, which is we want to return. So let's say we want to return only the even number, for instance. So we say if I modulo 2 is equal to 0, we want to return I, right? So normally in functions, you use return I. So it's going to return a stream of data for you. But we don't want that. In generator, you use yield I. Okay, so when you see a yield statement, that is a generator function. So at the end of this, I say yield I, so it gives us when we need it and doesn't store in memory. So let's say y is equal to generator function, and we want to now loop through that generator stored in y. So we say for I in y, we want to print I. Let's see how this runs, and I'll explain it again. So we have this generator function. We are getting it all the even numbers 0, 2, 4, 6, 8, 10, 12, 14 printed out one after the other like that. Now we use yield to return something in a generator. But what if we want to do something different? Let's say we want to return the maximum. We want to return some numbers up to a certain maximum, for instance. That will give us a better example for you to see the yield. So I'll create a new function. Let me call this dev. I'll still call it generator function. And I want it to have like a maximum number to execute, right? I want to have a counter to start. So we'll say counter is equal to 1. So we'll set it to start at 1. And let's use a while loop and say while counter is less than or equal to the max number. So I'll set it from 1, and while the number, so if I, for instance, if I put 20, so it will start from 1, 2, 3. Once it hits 20, it stops execution. That's what I mean here. So I want to yield, so yield counter. So now this is the better example. Now what I'm trying to achieve here is to say I want it to return 1 at a time. When it goes there, 1 is less than the maximum, it yields that. Then we want it to do something. Let's say counter loss equal 1. So we can see here that at the end of it all, after the yield, we can still have something. If it were a regular function, after the return, you can't have anything after the return statement. That is the end of the program. So when we yield counter, we now increment, it goes back and do that, right? So let's call this and see. Let's say test is equal to generator function. Let's say I want to do 1 to 5, and now it returns. I call this function, I store it in a variable called test, and I want to loop through test, right? So I'll say for n in test, I want to print. So what it does now, it returns these values as is needed, but doesn't store in memory. So you say 1, 2, 3, 4, 5. When it yields here, it gives you an output, and then increments and goes over up until the maximum specified. The maximum I specified here is 5, so it does that up until 5. If I change this to 20 and I run, it's going to stop at 20, so it starts from 1 to 20. So now you get the points and the difference between a regular function and a generator function. The regular function use a return statement, and the generator function use a yield statement. What you need to keep in mind is that the generator function are memory efficient, they can use to represent an infinite stream of data, and they can also conserve memory by not storing anything in memory, and you can use them for data intensive development where you can have multiple chain yield statements to have this thing done in batches where you have a more efficient system. In our course Foundations of Software Development, we're going to use the generator function to see deeply and in real practical world experience how generator functions are more efficient and more useful in things like the Fibonacci sequence and things like that. So this is where we end this week's lesson. Thank you and see you next week.